Hello, I'm Jenny Madsen.
And I am Diego Juarez, and this is our ME223 LED project video.
There are lots of bite alarms on the market for fishing that let us know when a fish is biting. These are especially useful for when multiple poles are set up because our attention is divided. Alarms on the market tend to be bulky, over-engineered, or are just cheap. None of them plug into a compact unit, which gives their users a simple way to maintain lots of poles at one time.
We'd like to introduce Fish-On, a simple prototype that will eventually be an easy-to-attach all-in-one LED indication system for when those sneaky fish are trying to steal your bait. Fish-On recognizes a simple tug on your fishing line and activates an LED warning signal that a fish is biting.
Our system uses a simple mechanism which is attachable to any fishing pole. The weight of a fish biting bends the fishing pole, which in turn compresses the mechanism. A force sensor placed inside the mechanism talks to our computer, which signals an actuator when the appropriate amount of force is applied.
With the interest of the total success in the marketplace, we have taken the time to assess how our product appeals to consumer emotions. Fishers will want our product because it is simple and easy to use and attaches to all different types of poles, and it will reduce the chances of missing bites. Nothing is more important to a fisherman than getting their hands on fish. It's the ultimate bonding experience.
Having an indication light is extremely useful to children as they begin fishing and can be a fantastic training tool. In the interest of safety, none is better than Fish-On and reduces the chances of missing that big fish, or 3 if you have it set up to indicate multiple poles. Lastly, you can't compare to the excitement of flashing lights and a big tug on your pole.
So it's out there, and the market of bite alarms has been pretty well looked after. We think that change is great though, and we wanted to know what our competitors were up to. 3 of the best ones we found had the market cornered on size, simplicity, and doing just about everything you would want in a bite alarm. We compared our product to Moonstick, Sensotech Baby Bite Alarm, which isn't as punny as it sounds, and TXI Plus.
In order to see how our product would size up to the competition, we compared our product designs based on features we thought were important, including simplicity, functionality, battery life, LED brightness, etc. In this process, we found that it would be important to keep our product small and easy to use and attach to other poles while having the solid engineering necessary for hardcore fishing enthusiasts.
Our product is going to respond to the physical force exerted when the pole moves. Unlike other motion-sensitive products on the market, our product should be smaller than the competition. We want to decrease the total bulk while maintaining accuracy. It should be a good value and incorporate a modular system, which we haven't seen in these products.
Our system diagram is a simple display of inputs and outputs. Tension exerted on the pole when the fish bite compresses our sensor. The sensor inputs electrical signal into our Arduino. The battery inputs voltage into the Arduino, giving it the power to run, and our Arduino outputs electrical signal to the LED grid.
In our flow chart, we have a very simple mechanical force being converted into an electrical signal by our force sensor. The lights on our device are sensitive to how much force is exerted on the sensor and light up in series depending on that force. This is possible as the Arduino recognizes the signal from the force and outputs an electrical signal in response to the LED grid.
Not only is our design system simple, but so is the way in which the Arduino and breadboard operate to make the design work. 5 volts are ran through the schematic force when the force sensor is activated. This charge then passes through a 10 kiloohm resistor into the 3 560 kiloohm resistors, or 560 ohm resistors, and LEDs through ground. Based on the pressure applied into the sensor, one or all of the LEDs will light up. It's that simple.
Every engineering project has its technical challenges. Initially, we wondered how we were going to have our fishing pole talk to our board. We figured out that we could use the force sensor that came with our kit to translate the mechanical force into an electrical input our computer could read. Finally, as we were wrapping up the project, we decided to add not just one but a series of LEDs which would make our product more marketable. Adding the extra LEDs took time and required more knowledge.
In our project, we found that the iterative design was very effective. In correlation with numbering on pictures, we turned our LED on, used the force sensor to activate the LED, set up the Arduino blocks with pliers, which would be depressed to depress our force sensor with the pole. We came up with moment arm idea, which would connect our box to our pole and reach back into our Arduino control box. We found the box was just too heavy for any real application, so we put the force sensor on a long wire, making it into a probe, and attached it to the end of our pole. It worked the first time. It was extra sensitive. It was simple and sweet. Let's go fishing.
We came up with lots of ideas during our prototyping that would make using our product easier. We learned our final design would be all-in-one. We also learned that we could make a shield for the board, which would increase the number of LEDs and allow for multiple pole setup. We also learned that we could program the Arduino board to emit tones of different frequency for hits on different poles.
Now's the time where we wrap up what we've done for the last couple weeks. We feel that our project was a success for one, because we made an effort to have lots of meetings and didn't put the project off. Our design process was iterative, we had stuff ready to go for meetings, and we evenly dispersed the workload.
Every project has things that need to be improved. For starters, it is really important to always keep the list of deliverables for the end of the project in mind and be getting those done along the way rather than doing them all at the end. Getting concepts down now will greatly improve the quality of work time during the project, which is something that could be improved on.
Learning Arduino code and software basics was one of the best parts of this project. Working with solderless breadboards was fun and a great way to learn about electrical circuits. This project has continued to challenge us and keep us aware of how to work effectively within our time and hardware constraints. For now, that's all we have. Hope you enjoy. Fish on, and thanks for your time.